is 1 minus the sine squared of b. All right, so I'm going to choose this last one. I'm sorry, I forgot the 2. So 1 minus 2 sine squared of theta. Cosine of 2 theta, 1 minus 2 sine squared of theta. And this becomes 2 sine theta, or sine of b, cosine of b. All right? So sine of 2 theta, 2 sine theta, cosine theta. And so that's what you write in the first little block that they have. So they have like 4 little blocks. Now, if you distribute the negative sign, and I'm going to do this step, but they really don't want you to put this one in there. So this is going to be 1 minus 1 plus 2 sine squared b over 2 sine b cosine b. And the 1 and the 1 cancel. So the next thing that you're going to write into the block is 2 sine squared of b over 2 sine b cosine b. And if you look at this problem and look again at the 3 choices that you have to make out of 2 cosine of b, notice on this one I would have 2 cosine squared theta minus 1, and this one I have 1 minus 2 sine squared of theta, and this one I have cosine squared of theta minus sine squared of theta. So if I use this one, I don't have anything to cancel with that 1. If I use this one, notice that it would be something minus 1, so when I distribute that negative, it would be plus 1, and then I'd have a plus 2 over here, which I don't want. And so if I use this one, then you see how the 2 1s cancel, and then I just have 1 term in my numerator. So you may have to take more than 1 shot at this one to get it right, but if you think about it a little bit, you'll see that this is the one that you want to use, because notice only 1 term in the numerator here, so I need to get rid of this 1. So if I'm subtracting the 1, that they cancel. All right? So this is what you're going to put in the second little block. And then notice I can cancel the 2 2's. I can cancel the sine of b with one of these sines of b, and I get sine of b over cosine of b. And that's what they want in the next little block. And then finally you can say that's equal to the tangent of b. And I don't know why they put it over 1. You can put it over 1 if you want, or you can just leave it as the tangent of b. And then finally, problem number 6 on this one says the cotangent of x is equal to 9/4, and it's in quadrant 1. So that tells you that the tangent of x is equal to 4/9. So this is opposite over adjacent. Or I could do it over here, but I always like to do it. It seems like everybody does better with knowing the tangent. Now this one I don't actually need to draw the triangle, because all they're asking for is the tangent of 2x. So I could use the cotangent form of it and draw the triangle, or I can just use the tangent form of it, because the tangent of 2x is just tangent of x over 2 tangent x over 1 minus tangent squared x. Let me find that formula. Tangent of 2 theta equals 2 tangent theta, 1 minus tangent squared theta. And I know I keep going back to my formula sheet, but I do that for a reason, and it is because you need to get used to this formula sheet so that you can know where to look when you're taking your test. All right? So now let's just plug in 4/9 for the tangent of x. So this would be tangent of x is 4/9, so 2 times 4/9 over 1 minus 4/9 squared. So this is over 1, so I get 8/9 over 1 minus 16 over 81. This is over 1, so multiply numerator and denominator by 81. So I get 8/9 over 81 over 81 minus 16 over 81, which is 8/9 over, and then 81 minus 16 is 65 over 81. And so this would be 8/9 times 81 over 65. The 9 and the 9 will cancel. The 9 and the 81 will cancel to give me a 9 in the numerator. So I get 72 over 65. And that is your final answer for that one. All right. So I think that answers all the questions on section 9.3. So I'm going to do the video problems on another video.